So in this video, I'm going to explain the instruction STAX, which also comes under data transfer instruction set. So the meaning of this instruction STAX is store accumulator indirect. Later we'll see that their functionality in detail. So first of all, we'll see their opcode. So the opcode for this instruction is given as STAX, and as like LDAX, the operand for this instruction will be either BC register pair or DE register pair. So here we can write this as a B or D register pair, and now we can understand their functionality with example. So let's say, for example, this instruction is written as STAXB. So what is the function of this STAXB? This ST means store. This ST means store, and here this A means accumulator, and this X means register pair. Which register pair? So here as like B it has mentioned, so B register pair. So store the content of accumulator through register pair. It means in this instruction through BC register pair. So what is the function of this? This BC register pair, whatever is the content of this BC register pair, it will be work as like the memory address of that memory organization where the content of accumulator has to be stored. So let's say, for example, if I am starting this instruction at the address of 1001H, so first of all, their opcode will stored before execution of this. So their opcode will say here as a 02H. So once this opcode will come from the memory to the processor, so after the execution of this opcode, that processor is knowing that we need to store the content of accumulator into the memory location whose address is specified by BC register pair. So before execution of this instruction, if this BC register pair is having somehow their values are 20H, 50H, so in this memory organization, what will happen? By the use of this instruction, this will point to the address as a 2050H. So this BC register pair will be pointing to this address, and whatever is the content of the accumulator will be storing into this location. So during the execution of this instruction, the second machine cycle will have the address of the content of BC register pair. So as like the BC register pair is having the content before execution of this as a 2050H. So this will work here as a address for that data. So now here, let's say before execution of this instruction, if the accumulator content is having 97H. So at this location 97H of the accumulator data will be storing. So now here, after execution of this instruction at this location, we will have here 97H. So here, after execution of this instruction, the content of BC register pair as well as the content of accumulator is not going to change. What will change? That after execution of this instruction, whatever is the address pointed by this BC register pair as a 2050H, so that location content will be modified as 97H. So this is the functionality of this instruction. Now we can find out their size. So their size will be in terms of byte, as like in this instruction specification we have only English alphabet. It means their size will have only 1 byte, and their machine cycle will be how much? So for complete execution of this instruction, it is required, or it is accessing this memory location or memory organization 2 times. One is for opcode fetch. So here this first operation is called by default for any instruction is opcode fetch, and the second operation it is called here as a we are storing the content of accumulator. So accumulator is residing inside the processor and it is going to store into the memory. So if the data moves from processor to memory, then that operation is called here as a memory write. Memory write operation. So here it is having two operation, that is called two machine cycle here. So this will be specifying two machine cycle. One will be opcode fetch and another one will be memory write. So if you compare this instruction machine cycle with the previous as a LDX, then only the difference is as a second machine cycle. Here in the case of STX it is memory write, in the case of LDX it was memory read. That is only the difference with respect to machine cycle. So similarity is this will also take two machine cycle and LDX also will take two machine cycle. So as we know, by default for the opcode fetch operation it is required 4 T state here, and for the memory write operation it will take 3 T state here. So 4 plus 3 it will become 7 T state. So total number of T states required for the execution of this instruction is 7 T state here. So by this way I hope you understand this instruction in the better way. Thank you.